Hello guys, today we're doing LeetCode question 1492, the Kth factor of n. This is a medium question, but I would really say this is more of an easy question when you think about it. The question is, you are given two positive integers n and k. A factor of integer n is defined as an integer I, where n modulo I is equal to 0. Consider a list of factors of n sorted in ascending order. Return the kth factor in this list, or return -1 if n has less than k factors. So example 1, input is equal to 1 is equal to 12, k is equal to 3, the output is 3. Explanation, factors list of 12 is 1, 2, 3, 4, 6, 12. The third factor is 3. Example 2, input n is equal to 7, k is equal to 2, output is 7. Factors list is 1 and 7, the second factor is 7. Example 3, n is equal to 4, k is equal to 4, output is -1. The factors list is 1, 2, and 4, so there's only 3 factors. So we should return -1 as there is no 4 factor. So this is fairly simple. We'll just go through a for loop and we check if n is divisible by that value. If we do, we push it to an array, and then at the end we see if k is bigger than the array length. If it is, we return -1, else we return the value of k within the index of k within the array. So let me show you how we would do this. We'll use this example here, n is equal to 12. So let's say we have n, which is 12, and k, which is 3. All we do is we loop through an array starting from 0 up until 12. So we'll start from k, n. Actually, we can start from 1 because 0 cannot be a factor of 12. So we'll start from, I is equal to 1. And then we check if n modulo 1 or modulo I is equal to 0. So let's start by saying, so 12 modulo 1, is it equal to 0? Yes. I forgot to mention we create a list where we store all the factors. So since it's a factor, we push 1 to the list. Then we increment I. I is not equal to 2. Is 12 modulo 2 equal to 0? Yes it is, so we push that to as a factor. Then we increment I is now 3. Is 12 modulo 3 equal to 0? Yes, so we add that to the list. I forgot to mention modulo pretty much is we divide it and we return the remainder. So 12 divided by 3 is 4, remainder 0. That's why we know it's divisible by 3. That's how. So then we increment I is 4. 12 modulo 4 is equal to 0? Yes. So we push that because we can divide 12 by 4 3 times with no remainders. Then we increment I is equal to 5. 12 modulo 5 is equal to 0? No. 12 divided by 5 is 2, remainder 2. So now we increment I again. I is now 6. Can we divide 12 by 6? Yes, 12 modulo 6 is equal to 0. We can divide by 2. It divides it into 2. So we push 6 to the list. And so forth. The next will be 12. So the final value will be 12. And 12 can be divided by 12 one time with modulo 0. So we have 12 as a list. So now we compare k to the list of length. We can see k is smaller than list of length, which means we do have a modulo of k. So k, the third factor of 12 would be 3. So we will return 3 as we're asking for the third factor. Let me try to do this in code. So first thing we do is we create a list or an array. Then we have to loop through. So for let I is equal to 1, as long as I is smaller than n dot let n, that's it, smaller than or equal to n, because we go up until the number to check for a factor, then we increment I. Now, in the for loop we check if n modulo I is equal to 0, then we know it's a factor, so we push it into list. So list of push I. Now we check if n dot length is bigger than or equal to k, then we know we have the k factor. So we return list k minus 1. Sorry. Yeah, k minus 1, because the first index is 0. So you have to return. So pretty much, since the first index is 0, we know that, let's say, the third index, if we return k, 3 would be 4. We need to actually position. So we return it back. We decrease it by 1. And then, if we don't have the kth element, we return minus 1. Let's run that. If n.length is bigger than... sorry. Here is a mistake. If list.length is bigger than or equal to k, then we return list k minus 1. Here you go. That passes. Let's submit. As you can see, this is the fastest method. It beats everyone else. This is a time complexity of On. We're looping through 0 to n. And the space complexity of On, worst case, all the numbers before it are factors as well. Thanks for watching.